Welcome back to a new video. In this video, we will see integration by parts, a general formula. Okay, so I'm this side, the right hand side, I'm writing the formula, and left hand side we will see what application. All you know, if you have product of two functions and if you want to integrate with respect to x, then by integration of parts, what do you do? First of all, you have to decide which function you take the first function and which function you take the second function. Right? First you decide which function you take the first function and which one is the second function. Then what do you do? So you have to write down the first function as it is, the second function times second function, you know the integration of the second function minus the big integration sign, which function you will integrate. So here you take the derivative of the first function with respect to x of the first function, then time integration of the second function. Whatever you get after taking the product, whole thing you have to integrate. So this is the integration by parts if you apply one time. Okay. So now let me introduce a notation. I called, let's say, u u1 mean the derivative of the function u with respect to x, u1, and similarly u2 mean second derivative of the function u with respect to x, and so on, right? So whenever I write in power some number, mean you understand you are taking derivative of that function as much time, right? And one more symbol I will introduce here, this side. Okay. So v1 mean I am taking integration of v with respect to x, first time integration, and then v2 mean you are taking integration of the previous one, v1 dx, and so on, right? So whenever I write v suffix k, mean I am taking integration of v function consecutively k times with respect to x. So these are the notation. Okay. Now what I do in terms of this symbol, how it look like this formula. So here u and then v1 minus the integration, right? And then you are taking derivative of u with respect to x. So u1, then v1, and then dx. Okay. Now what do we do? We again apply here integration by parts. What you get, u of v1 minus, then let's take this is my first function in this case. So u1 as it is, integration of u1 dx. Okay. So here I have bracket minus then big integration, derivative of u1 then integration v1 dx. Whatever result we get, we will integrate. This is how it is designed, right? So now let's say this is what this is u of v1 as it is minus inside bracket. So this is as it is u1. Now this is what the two time integration of v with respect to x, because already you did one time, then next you are doing integration. So second time integration. So that is by symbol v2, then minus the big integration sign. So here see the double derivative of u. So this is my u2, then this is v2 of x bracket. So if you remove the bracket, u v1 minus u1 v2 plus integration of u2 v2 dx. I hope you understand the pattern. So next, if you again repeat the integration by parts here, what you get? So let's say dot 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 dot. So at some time, what you get? You will get u v1 minus take the derivative of u with respect to x, then integration of v second time, then plus sign u second derivative, then integration of v third time, then minus, and alternatively, so then u3, then v4 plus dot 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 dot. So where you stop? So it depends how many times you have to take this. You have to repeat this process. That plus you will stop. Okay, got it. So this is the general version of integration by parts. What I did here, I repeatedly apply integration by parts consecutively. Then we see this pattern. Okay. Now one thing you note here that we are taking derivative of u function and integration of v function. Now one thing you note that if you have a polynomial px is a polynomial of degree let's say k, then you know the derivative of this polynomial with respect to x n time n, so this should become 0 if for all n greater than k. So if you take derivative of a polynomial more than its degree, then you get the 0. You all know this, right? Because dpx of x square is basically your square. Second time derivative you take, then you get 2 here, then the third time derivative of x square. So constant this derivative will become 0. So that's why degree 2, 3 time derivative becomes 0. So in general it is 2. If it is a polynomial of degree k, then n time derivative of that polynomial is 0 provided n is more than k. So this is very useful result. So from here you guess that which function you take u. Especially if you have a polynomial, definitely I select u by polynomial. Okay? Because you will take the derivative of u function, and after certain time it will become 0. So this series will stop at certain time. So I am taking one example. So let's say I want to calculate integration of x cube, the sin x and then dx. So if you apply integration by parts, the single time I make a simple form, then it will take lots of time. Repeatedly you have to apply. Without using this single step integration by parts, I am using the general form. So yeah, in this case, definitely u is x cube and v is sin x. Okay. So now look at this formula. What you have to do in time integration of v function. So what is one thing to note here that u is a polynomial of degree 3. So uk is 0 for k greater than or equal to 4, right? Equal to degree 3. So here, so we don't want this is here. So therefore, the fourth order derivative of u function is 0. So in this series, if you write down that how it look like, u v1 minus first derivative of v2 plus u2 v3 minus u3 v4, then u4 is 0. So remaining all will be 0 here, whatever term we have, right? So you don't require to go more. So now let's apply here. So the u as it is, so x cube. What is v1? v1 means integration of this with negative cosine x. Integration of sin x is negative cosine x minus derivative of this is 3x square. Then integration of this again will become negative sin x. Then plus derivative of this, what I wrote, yeah, plus derivative of this will be 6x, and integration of this will become cosine x. Okay, then minus, the derivative of this will become 6x, right? So 3, 2, 1, 6, this place would be 6, then integration of this is sin x. Okay, so I took the derivative, this is derivative, then again derivative, then again derivative. So this is here dx we apply, again ddx, here ddx, according my formula, and for this I use integration, for this I use integration, for this I use integration. So within a minute you can calculate integration of this type of function if you apply the general form of integration. So this is very useful and important formula, especially for a competitive exam. You can apply this formula, right? So whenever you have a formula in mathematics, try to generalize it, and you can generalize. If you spend time 2-3 hours, you can generalize any formula. You have to imagine, you have to analyze the formula, and then you can generalize it. This is how mathematics work actually. So yeah, this is how it is working. So this is the general question of integration by parts. Hopefully you understand. Thank you so much. See you in the next video.